video is going to be a review of the end of year, first year SLAA exam. Just looking at the calculator, so part 2 of the paper. There should already be an earlier video looking at part 1. And we're going to run through questions for both the morning test, which was Europe and Asia, and the afternoon test, which was the Americas, at the same time. So I'm going to go on to present screen mode, where we'll be able to start looking at the questions. Okay, so you should now be able to see my computer screen, both a calculator screen, and you might recognize your questions. So in general here, the question on the left is the question that appeared in the morning test, and the question on the right is the one that appeared in the afternoon test. And you'll notice that in the vast majority of cases, they are very, very similar, just a slight difference in numbers. So if we start with question 1. Question 1 was the first question on the paper, designed to be quite a nice introduction. It was a fairly nice, straightforward setup of a binomial expansion question. And we'll look at the Americas one first. So part A, we've got our expansion here, x plus 2 to the 9, and we're told we specifically want the x6 term. So you may have started off like this and started listing all of your binomial terms and so on until you got to x6. But usually we do these questions using the general formula that is in the formula booklet, which is NCR, a to the r, b to the n minus r. And our a is the x, our b is the 2, and the 9 is the n here. And this is useful when you want just one particular term, you don't want the entire expansion. So we were told we wanted x6. So that makes this term definitely x6. So our r is a 6. And then the b term is the 2. And so if we've got n minus r here, that needs to be a 3. Because the n was 9 and the r was 6. So n minus r, 9 minus 6 is 3. And if this one here is a 3, then the NCR becomes 9C3. And you would get 2 marks for writing this, for identifying the correct term and having the components correct. You will need your calculator to find NC3. You could draw Pascal's triangle, or you could do the factorial n over factorial rn minus r formula, but your calculator can do it directly for you. So in the run part of your calculator, you want to find the NCR button. So to do that, you're going to go to Option. You're going to go across to the second menu. You're going to choose Probability, and we can see NCR here. So we want 9C3, and it tells us that it's 84. So 84x6, and we know that 2 cubed is 8. So we want 84 times 8, which is 672x6. So you'd get another mark for this, and then the final correct answer mark for the 672. If I had have done that for the Americas one, so yours, look, you'll know is almost the same, but you have a power 10. That's the only difference. So when you use your general binomial term, you've still got x6 here, but your 2 to the power n minus r would be a power 4. These 2 powers always have to add up to the n. So if this is a 6 and your n is 10, this is a 4. And so yours becomes 10C4. So for you, we're going to do 10C4, and we get 210. And 16 for 2 to the power 4. And if we work that out, we get 360 x6. So that's part A for both of them. Part B then, if it had gone straight to part B, this would have been a trickier question. But like a lot of IB questions, part B depends on part A, and having done part A makes it easier for us. So the important bits to read in the B question is that we notice this expansion is the same as what we've already looked at, and it uses the word hence, which is your hint of use what you've already looked at. We want the x7 term, and we've got a 5x in front of it. So if we want the x7 term, why that's relevant to the first question is we've got an x in the front here. So whatever is in this bracket, the power of x will go up by 1 when it's multiplied by 5x, which means we're interested in the x6 term in this bracket, which is what we already got from part A. So although this question really means 5x times lots of terms, the x9, this first term, and so on, including our 672 x6, we're only interested in these bits here. We're not bothered about the rest of the content of that bracket. So all we need to do is multiply our 672 times 5, and we get that we've got 360 x7. And if we do the same thing for part B on the Americas test, so 5x, but for you it would be the 3360 x6, you would have got 16,800 x7. So B a little bit trickier there, but A quite a nice straightforward binomial one. Right. Question 2. So question 2 was a geometric sequences question. And again, not designed to be particularly challenging, but requires using your calculator correctly and reading the formulas correctly. And do remember, the first version of the formula booklet has a mistake in it, so it's important that you use the most recent one that you were sent. So it talks about an infinite geometric sequence, and it tells us that the first term is 4. And it tells us the sum to infinity is 200. Now, the formula for the sum to infinity is u1 over 1 minus r. So that means we can say that 200 is 4 over 1 minus r. And we want to solve that equation. And we could do it in Solver, but most of you probably use normal algebra. So 200 times 1 minus r is 4. 1 minus r is 4 over 200. And so if I move the r to the right and the 4 over 200 to the other side, and we put that in our calculator, we get that r is 0.98. And in the Americas test, yours would have been very similar, except your setup would have looked like 250 on the left for the sum to infinity, and your first term was 5. And so your algebra would have looked like this. And actually, you get the same answer out the other end. So you still get 0.98. And you get a mark here for this equation and a mark for the correct answer. And I've just realised that I've cut off 2B from this question and I've forgotten what it was. But I think almost everyone who got an answer for part A was able to do part B. I think it asked you for a particular sum or something like that. So we'll move on because I don't remember what the question is and I don't want to interrupt the video trying to find it. So question 3. Question 3 was a calculus question testing some of what we've looked at most recently in calculus. So starting with part A, we've got a function f of x and we're asked for the derivatives. Again, the formula booklet is useful here. The formula booklet tells you the derivative of ln x. It tells you it's 1 over x. It tells you the derivative of e to the x. It tells you that the derivative of e to the x stays the same. But we haven't got e to the x, we've got e to the 0.5x. So what we have here is one of those situations where we have an outer function, the e, and an inner function, the 0.5x. So when we differentiate that, we differentiate the outer function first, which is the e, and the formula booklet tells us that e stays the same. So this will look like e to the 0.5x. Then we look at the inner function, the 0.5x, we differentiate that, which is 0.5, and we multiply our answer by it. And we probably want to write this a slightly nicer way and put the 0.5 at the front. You wouldn't lose a mark if you left it like this, but it looks a bit messy. And you get a mark for each term here. So a mark for 1 over x and a mark for this guy. And then on the Americas one, yours would look very similar. Your first term is exactly the same. And then your second term, you've got e to the 0.4x. So the only difference is that you've got 0.4 here, and so the derivative of your inner function is also 0.4. And so your answer was this. And then part B. So part B wants a second derivative, which means you want to differentiate the question we've just answered. So before we do this, it might make sense to put our previous one in index form. So instead of 1 over x, we're going to write x to the minus 1. And when we differentiate that, now that's a fairly simple differentiation to do. So there were some mistakes where people didn't write it in index form and then made an error when differentiating this one. So minus to the front, x minus 2. And again, we've got this situation with the inner and the outer function. So we have an outer function of e, an inner function of 0.5x, and we've got another 0.5 that's already at the front. So the 0.5 at the front, we're just going to leave there. The outer function, we're going to differentiate, and it stays the same. The inner function, 0.5x, its derivative is 0.5, and we want to multiply our answer by that. So I'm just going to put that at the end. And like before, I'm going to simplify my final answer. I've got a 0.5 times another 0.5, which is 0.25. So it's better to write it this way. And again, here it's a mark per term. So the Americas one, so this was f double dashed of x. The Americas one, your first term obviously going to be the same thing because it was identical, but yours would have minus 0.4 e to the 0.4x times 0.4. And so your final answer, your 0.4 times 0.4 would be 0.16, like this. And then part C. And part C is why I've got my calculator on the left here, because we can't solve this without using a calculator. Okay, it's not possible. So part C wants us to solve essentially our answer for part A equals to the answer to part B. And you've got two choices about how you do that. One option is in your menu to go to equation, to choose solver, so F3, and just to type it in. And you'll notice that actually I've already written it in there, but we'll do it again. So 1 over x, 1 over x minus 0.5 e to the 0.5x equals, need the equals down here. And then, so that's the f dashed of x, and then the f double dashed of x is minus, and make sure you choose the minus in the brackets here, x to the power minus 2. And then minus 0.25 e to the 0.5x. I usually put 0 as a starting guess, although you can choose anything. And then if we solve it, we get the answer. And it tells me that x is 2.09. The issue I have with the solver one here is this question just said solve. It didn't say find the value of x or find the values of x, just said solve. And the issue with that is it doesn't tell me how many answers there are. There's no hints in the word value or values. So I don't know if there's one answer or two or more. I can guess that perhaps there's only one because it's only 2 marks. But that's not a guarantee. And the issue you have with solver is there's no way of knowing if there's more than one solution. In this question, there is, in fact, more than one solution. There's 3 values of x, but luckily for us, the other 2 are negative, so they're not valid, and we don't have to worry about them. So rather than use solver, I would have chosen, actually, to graph this. So when we graph it, and I'm going to do this first function here, I'm going to do 1 over x minus 0.5 e 0.5 x there. And I could type in for y2, the function I've got here, but I can be a little bit smarter than that. I'll just delete the one that's already there. And I can use one of those inbuilt functions of the calculator, which is it can graph derivatives for me. So I can tell it, I can choose options, and I can choose calc for calculus, and I can choose d by dx, and tell it to do d by dx of my y1, which is the function up there. And I can put x equals x into here. And what that will do is the calculator is going to graph the derivative of this one for me. And since this was the second derivative, it is, of course, the derivative of this first one. I could, had I wanted to, have put the fx formula in first and told it to do d by dx and the second derivative, and it would have done that for me as well, but then I would have had 3 graphs. So I've chosen just to have this one typed in as my answer and then this one as the derivative. I'm going to go to I'm going to try and go to my window. And just to check, I only want a minimum value of 0 for x because it tells me to only look at positive x values. And I'm probably going to choose some sensible values for the window. So I might put 10 as a maximum for x. And the y's, I might put minus 5 to 5. And that's just because I don't really know the size of this graph. So that's kind of fairly small numbers to start with. If I can't see enough of it, I'll pick some bigger ones. And then we go to draw. And there are our 2 functions. So the scale I picked worked well enough. I didn't need to go up to x being 10, but I can see what I want. We can see one intersection there. And if we do gsolve and then intersect, it's going to give me the same answer we had already, 2.09 for x. If you're wondering how to get a method mark on this question, what you need to write was either say I wrote y1 equals y2 equals found the intersect on my calculator, or better yet, just do a really rough sketch and say intersect an x value. And even if that's wrong, you would get a method mark. But you do need to sort of explain what you were doing to get that mark. Like I said earlier, there are actually some other solutions here, but this is more reassuring because I can see that for x below 2, there's definitely not another solution. The graphs are going opposite ways. And after 2, they look like they're going apart. They're diverging. So I can feel fairly happy there was only one answer. Had I chosen a different window, I would actually have seen that there were other answers, but just outside of our domain. And as you can see, there is an answer at x being around -1 maybe, and then another one here that would go off my window. So there were other solutions to that equation, but just not in this domain that they tell us to use. Okay, so that's where the graph function can be more useful for solving equations than solver, because you can see what's going on. So if I was to do that for the American question, then all I would need to do is change these to 0.4s. And again, I've left it on this window, but we're going to ignore your negative ones. And so I want the intersection, not the one that's found first, but this one. And you get an answer of x equals 2.34 for your part C. Okay, moving on. Question 4. So question 4 was identical on both papers because it had a diagram that we didn't want to change. So a key bit to do with this one is the moment you read it, it tells you that theta is in radians because it's from 0 to pi. So pay attention to that because you want to make sure before you do anything else that in your setup, so that's shift menu, that you're on rad here. And if you're on dead, you want to go down and change it to rad. Okay, otherwise you're going to get funny answers, which some of you did. So it asks us about the area of the shaded region, so this bit here. What we can see is the shaded region comes from the area of the sector that I've just drawn out in red, taking away the area of the triangle that I've drawn in blue. So I can write area equals area of sector minus area of triangle. And you get a method mark for trying that approach. Of course, I need to find out what those areas are. So starting with the area of the sector, the formula for the area of the sector is half r squared theta, which is in your formula booklet. So for us, that's half. The radius is 4, and then theta is theta. And that simplifies to half times 16, which is 8 theta. The area of the triangle, there are a few ways you can go about doing the area of the triangle, but the quickest is probably to use the half AB sine C formula. So we have a half, and both the A and the B are 4s. Yeah, the two sides, either side of the angle, are both 4s. And then sine theta. So we have a half times 4 times 4, which is also 8, and we have 8 sine theta. So our area is 8 theta minus 8 sine theta. And you get 3 marks for that. So there's a mark for doing these, then a mark for correctly substituting the numbers in, a mark for the final answer simplified correctly. And then part B, the area of the shaded region is 12. So that means we can say that 8 theta minus 8 sine theta is 12. And we can't solve that with algebra. It's not possible because there's a theta and a sine theta, so we can't get theta by itself. We need our calculator, and that's why this is on the calculator paper. So again, I could use Solver or I could use Graph. I'd be inclined here to use Solver because, first of all, it says the value of theta. So there's only one of them. And second of all, I know it's between 0 and 3.14. So as long as I get an answer in that range, I can assume I found the answer. So in Solver, we will type it in. 8, except we're going to use x's and not thetas. So 8x minus 8 sine x equals to 12. I'll put 0 as a starting guess. Click solve, and there is our answer. X equals 2.27. Okay, and that was fairly straightforward if you've remembered that your calculator is there and you've made sure you're on radians and not degrees. Okay, question 5. So unlike some of the questions, is a bit more challenging in the sense that it gives you lots of information, so lots of instructions at once. It's not just find this, and there's a bit of a story to it. So it gives us a function, f of x. It tells us it's got this letter k in it and that it's a constant. It tells us that the function goes through this coordinate, 4, 2. It tells us then that there's a minimum point on the graph, and then it asks us to sketch it. So there's quite a lot to do there. And if we go to the end instructions, sketch the graph, well, of course we could do that. Just go type it in here, but we'd immediately see the issue is we've got a K and we don't know the K, so how can we type it in? So that's going to be our first task, is to find the K. But that's why they've told us this line here. The only purpose of this one here is because it tells us, it gives us a way of finding the K. So if it goes through 4, 2, that means f of x is 2 when x is 4. And if we simplify that, we get 12 plus 16k minus 58 is 2. If we move all the numbers to the other side, we get 48 is 16k, because we get 60 and then minus 12, and so k is 3. Now we could go ahead and sketch it. So I'm going to delete the second function because I don't want to see that one, and we'll go in here and we'll type this one in. So 48 over x plus 3x squared minus 58. This time we know exactly what we want to set our window to because we've got the values here. So we can go to shift window, we can say make minimum x 0, maximum 6, minimum y negative 30, and up to 60. And then back to draw, and there's our graph. And essentially the marks come from sketching that. So let's go on black. Marks come from sketching that graph. Before we sketch it, it is a good idea to mark the edges of your window. There's often a mark for that, not always, but you always want to be safe, especially if it tells you a specific domain. You want to make it really clear you weren't lazy and graphed it for bigger values. We can kind of copy that picture as it is, pretty much. Okay. But what's important in this sketch is marking on the key values. So we're told about P, so we want to find its coordinates, and then we have our two x-intercepts. And we can do that using the calculator. We can get it to do the work for us. So for the minimum, we can do gsolve. We can do minimum. There's only one. It gives us those coordinates. Write those in. And then for the x-intercepts, you need to remember that they're not called x-intercept. They're called roots, because they are the solutions to f of x equals 0. And the name of those is roots. So we pick root. Tells us the first one. And remember to write it to 3 significant figures, so 8, 6, 1. And then the second one, 3.90. And now we've got all the important things on our graph. But just before we do, a really good way to check that we've typed this in correct and that we got k correct is just to double check, is that really on our graph? Because if it is, we can feel pretty confident that we got this one right. So if we go to trace lets you move left and right along the curve, but if you type things in, it makes them the x values. If I type 4 to make x 4, you can see it comes up with that box there. And if I press enter, it'll go to exactly 4, and you can see it's telling me that y is 2, which means this is definitely on the graph I sketched, so I can be pretty confident I did this question correctly. So some useful little GDC skills in your exam can help you know where you've made a mistake. And some of you did make a mistake with k. That would have hinted to you, just go back and double check your k. Yeah, see if you can find your mistake. Right, last question. So again, a bit more of a sort of in-context story type question. And actually this was answered quite well. I was quite impressed with your answers to this question. So we're told at an amusement park, a Ferris wheel has a diameter of 111 meters. It rotates at a constant speed. The bottom of the wheel is k meters above the ground. A seat starts at the bottom of the wheel. So most of that writing is shown in the diagram. anyway. Okay, the only bit the diagram doesn't tell us is that the seat starts at the bottom. And it tells us the wheel completes 1 revolution in 16 minutes. So another way of saying that is that the period is 16 minutes. And it tells us after 8 minutes, the seat is 117 meters above the ground. Find K. And most people got this question correct, but we'll look at it anyway. So the important bit here is that this is 8 minutes, not some random time in minutes, but 8. And that means it's exactly half of doing the full revolution. So it means it must have reached 117 halfway round its rotation, so when it's right at the top. And since this distance is the diameter, 111, and this is K, it means we can say, oops, wrote 6, it is 6, I meant to write K. It means we can say that 111 plus K is 117, so K is 6. And parts B and C are a little trickier. So for B, we're now going into something about equations. Yeah, we've got a trig equation here. So it says after t minutes, the height above the ground is given by this. For 0 to 32 for t, find the value of A. But we know some information about time and height. We know that at time 8, the height is 117. We actually also know that at time 0, the height is 6, and we could have used that. But the more obvious one is the one they've already told us. So we know that when t is 8, that h is 117. So we can write that in. 117 is 61.5 plus A cos pi by 8 times 8. And we could go and solve this on our calculator for A, but we don't actually need to. We can do it a little bit ourselves. So what we have here, the 8's cancel, and we just have cos pi. And cos pi is equal to -1. And if you weren't sure of that, you could have typed it in your calculator. It would have told you so, as long as you were on radians. Otherwise, you'll get some funny numbers. So actually, this means that 117 is 61.5 minus 1 times A. And if I move the A to the other side, 61.5 minus 117. If you put that in your calculator, you get minus, well, let's do it, oops, not there. 61.5 minus 117 minus 55.5. There are other ways of going around this question, which is to realise that A would be the amplitude of the cos function. And since the cos function goes between 117 at its max and 6 at its beginning, so the cos function would be cycling between 117 and 6, A would be half of that gap. But you then also have to realise it's negative, because a normal cos function would start at the top and then go down, but our wheel is starting at the bottom and going up, so it needs to have a minus to that to sort of flip the cos function or reflect it around the x-axis, vertical reflection. So I think it's a lot easier to do this one by just putting the numbers in the equation rather than trying to think of the transformations. And you can, if you did it that way, you could always then check if it worked. Right, part C. So part C, a lot of people got 1 or 2 out of 3, but not quite the full marks. The main issue here was in getting the correct time it hit 30 meters. So the question says, find when the seat is 30 meters above the ground for the 3rd time. So we can take our equation and set it equal to 30. And we now know our equation is this. And we could solve that directly using Solver, and you will get a number. You'll get t as 2.46. But that will only tell you the first time you hit a height of 30. So we're starting here, and we've got a height of 30. And then the first time we hit it takes 2.46 minutes. oops, sorry, the first time we hit it takes 2.46 minutes to get to here. But then we keep going round, and then we hit 30 on the way down, and then we keep going, and we hit it for the third time on the way up. So actually we want to take that 2.46 minutes and go round a whole nother cycle. So adding 16 in this case to get 18.46. And you can do it that way, but a much better way to do this is just to draw the graph of our function. And then we can see what's happening, and we don't have to think, do I need to add 16 or minus it, or what other things do I need to do? So let's do that. Let's go to graph. So we want to type in our function 61.5 minus 55.5 cos pi over 8 times x. And again, we're using x's because the calculator's default is x. And we're also going to want to see a height of 30. I'm going to go to my window because, again, I've been given a domain. I know that the time is between 0 and 32. Oops, not 332, just 32. Oops, didn't mean to go out of that. And then the y values, it hasn't given us the y values, but we can work that out ourselves. We know the minimum height is 6 and the maximum is the 117. So a sensible thing to see on the calculator is 0 to 120, and we'll be able to see our whole graph. And there it is. And we can see that it's doing its 2 whole cycles in its 32 minutes. And then our red line is our 30. So if we want to find when they intersect, so when the blue line is also at 30, we can do gsolve, we can do intersect, and there's the 2.46 I mentioned earlier. But this time I don't have to worry about, well, I've got one answer, how do I find the specific answer I want? I can just say, well, there's the first time, there's the second time at 13.5, here's a third time, 18.5 minutes. So doing it by plotting the graph gives us a much easier way to decide which specific answer we want. And we can see there would have been a fourth time if we were interested in it. Okay, so I hope that that helped with some of the solutions to the second part, the calculator part, and with where some of the marks came from. I will stop sharing my screen. And I'm back. Okay, so I hope that helped. Please speak to me or Matt if he's your teacher if you've got any other issues. But this will stay on YouTube, so you can always go back to it in the future if you want to try this exam again next year or something. All right, goodbye, everyone.